Hello everybody, welcome to episode number 1 of the BIVBlog, Benedict's IT video blog. My name is Benedict Stockebrand, and today for the first episode I'm going to tell you how to come to grips with the tremendously large size of the IPv6 address space. Now, you probably know that IPv6 addresses are 128 bits long, so they are 4 times as long as IPv4 addresses. And that means obviously that with IPv6 we have 3/4 of the address space still unused. At least that's the sort of conclusion allegedly then Minister of the Interior Dr. Schäuble came up with when somebody seriously tried to explain IPv6 to him. It's good enough to get you promoted to Minister of Finance, but if you want to do a technical job, that's simply not good enough. So how can we properly come to grips with this number? Now, first thing is work out the actual number, which is 2 to the power of 128, which is 340 gazillion. The number is so large that unless you're into number theory and don't have a life anyway, this number is simply not graspable to your mind. At least it isn't to mine. So that doesn't really work. What else can we do? Well, if we can't work the absolute numbers, we go for some ratio to some other things we can sort of handle. One of the first things people have come up with, that's like so many IP addresses per grain of sand on the world or per square meter of the world's surface or whatever, and you still get some impressive numbers which just don't mean anything to you or me or pretty much anybody else. So that doesn't really get us all that far. And what's worse, it's misleading. Why is that? Because it assumes that these addresses are actually usable. But the entire idea with the way the IPv6 address space is designed is that the vast majority of addresses will be unused, will be available in case we actually need an address. That's simplifying life quite a lot, but we pay for this with very, very sparsely populated address space. Long addresses we have to transmit with every packet. So what else can we try? We could try to put the number of IPv6 addresses into ratio with the number of IPv4 addresses, which is 2 to the power of 128 divided by 2 to the power of 32, which is 2 to the power of 96 divided by 1, which is just another one of these numbers, which is what we would expect anyway, because we again don't take into consideration that the IPv6 address space is sparsely populated. Okay, so we're probably running out of ideas by now. Well, at least I was some years ago when I first tried to come to grips with this, but since then I've found a way to make the IPv6 address space more easily graspable. To explain it properly is a bit more difficult than these fairly straightforward comparisons, but what we can do is something like this. Back in the old days, when I was still a bit younger and even more beautiful than I am these days, IPv4 addresses were managed and handed out by the Internet Assigned Numbers Authority, which was at that time a certain John Postel. And if you needed IPv4 addresses, he'd give you a class A, B or C network. Now, for simplicity's sake, let's assume he only gave out class C networks, which have a 24-bit prefix, so there's 2 to the power of 24 of them. Compare that with IPv6, there's RFC 3177, which strongly suggests to give people who want addresses a /48 prefix. So there's 2 to the power of 48 of these. And we put these into ratio, then we get an interesting number, one that we can kind of handle. If we divide 2 to the power of 48 IPv6 prefixes by 2 to the power of 24 IPv4 prefixes, as they were allocated to end user sort of people, then we get a growth factor of 2 to the power of 24 to 1, which is roughly 16.7 million. That doesn't look as impressive as the previous numbers, but if you imagine that number on your bank account balance, preferably without a minus sign in front, then it is quite impressive. Put another way, for every person in IPv4 world, we can have 2 New York City populations of 8.3 million each in IPv6 space. So that is a number. And it's also small enough to make it obvious that assuming that the IPv6 address space is for all practical purposes infinite is a very, very, very stupid idea. Now, in the next episode, I'm going to explain how to actually run out of IPv6 addresses, because there are ways to do that. But for now, let's call it a day. If you want to discuss this, hop over to the forum. Otherwise, hopefully see you next time. Bye.